Hello, and welcome to this tutorial on Distributed Data Parallel, or DDP, in Pytorch. Now this is a tutorial on distributed training for neural network models. So basically the purpose of this is to be able to train a neural network model over multiple GPUs, whether that be multiple GPUs on a single compute instance or multiple GPUs across multiple compute instances. Now, what you're looking at right now, and here is a tutorial that has already been put together by the Pytorch team. So thank you to Suraj Subramanian for putting it up, but it does skim over some of the intricacies of the deployment in an AWS environment. So that's what this video is going to be about. It's going to be about doing utilizing the code written as a part of this tutorial series within AWS. And effectively what that means is we're going to be setting up multiple EC2 instances in AWS to execute this code. And the setup for that is going to include what kind of software packages are needed to run this, and additionally how these EC2 instances need to be configured in order that they be able to communicate with each other to do this distributed data parallel training. So if you haven't already read or watched this tutorial series in terms of the one that Pytorch has put up, go and do that before watching this video because it assumes that you have already read it. Having said that, I'm going to give a brief recap as to what we're doing here and the purpose of it. Okay, so distributed data parallel is a method of parallel training in Pytorch. So specifically what we're talking about here is using multiple GPUs to train our model. Basically, more GPUs is giving us access to more computing power. It's allowing us to do our matrix multiplications, taking in more input data on a larger scale. Effectively, how this is going to be done is by either using instances that have more GPUs or by running across multiple instances on EC2. Running on a single instance with many GPUs is somewhat trivial. You can basically follow this single node multi-GPU training to the letter, and it's going to do you just fine. However, multi-node training, which is multiple EC2 instances with GPUs, is a little bit more non-trivial to set up. And so that's what we're going to be taking a look at here. So without any further ado, let's cross over into our AWS environment. This is our AWS EC2 dashboard. So what you can see here are a few EC2 instances that I've already kind of started up in order to explore this. However, what we're going to do is start right at the basics and look at how you would launch an instance to run this code. So first, let's take a look at launching an instance. So this is the tab that kind of gets opened when you click the Launch an Instance button. I'm going to walk through it step by step. First off, you need to change the name for your instance. This is pretty self-explanatory. Just choose something easy to remember that will help pick this out later. Second, and kind of first important thing, is choosing an Amazon machine image. So this is basically going to determine the operating system of your EC2 instance alongside any pre-installed packages. Notably here, we have picked a AMI that includes GPU drivers and a version of Pytorch on the Ubuntu system. So I just chose this in order to expedite the workload a little bit. However, if you want to create your own EC2 instance from scratch, you can absolutely do that. Not much more to say here, apart from the fact that this instance requires specific kinds of instance type. And so that is going to dictate what instance type we use in the next step, which is a g4dn.xlarge. This is a relatively cheap EC2 instance which has a GPU. As you can see, it's only 0.71 USD per hour. So I've chosen this because it's pretty cheap and it has a GPU, and that's about it. your key pair is going to be used to basically SSH into the instance. So if you haven't gotten the key pair, create a new one and download it. The network settings, here we have to choose a VPC. I'm not going to go through in this video of how to configure a VPC, but it's fairly basic. We don't need anything special here. The only thing that we require is that for when we do our multi-node training, that is when we have multiple EC2 instances spun up, they have to share a VPC. And that's because our EC2 instances are going to be communicating over this VPC using private IP addresses, not the public ones. The public ones involve a little bit more difficulty, and the EC2s have a little bit more trouble kind of connecting to each other. Whereas on their private IPs, they can connect just fine. That's all we need to do here. In terms of auto-assigned public IP, we want to have this enabled for simplicity here, just so we can SSH onto all of our instances just from our laptop or computer or whatever we're working with. In terms of security groups, this is another fairly important step. So here I've just clicked Create Security Group. I already have one existing, but just for the purposes of showing you what rules we need, here we go. So we've chosen a name and a description, but the important thing here really are our inbound security rules. So there are two key ones that we need. One is an SSH security group rule, which is just going to let us communicate in and enter our instance from our IP. And secondly, and more relevantly to this video, we need to set a custom TCP kind of range. Basically, what this is doing is it's allowing our EC2 instances to communicate between each other. This is how Torchrun is going to communicate. It's going to communicate using certain ports via TCP. So by default, Pytorch chooses the port 29400 to do this communication. However, and this is something that isn't immediately clear when you do the tutorial or when you look through Torchrun documentation, depending on what rendezvous backend you're using, it's going to select different kind of ports, and it's going to select different kinds of ports semi-randomly, actually. So NCCL, which is the backend used for our GPUs to communicate with each other, can kind of pick anywhere from 29,000 to all the way through to 65,000. So that's why this is here. So we're going to capture kind of the default port that Torchrun is going to communicate through, and also the NCCL backend. Note, there are some ways to control what TCP ports that NCCL is able to do if you're really concerned about that for security reasons. But it's quite hacky. I'll link a solution to that solution beneath this video. But if you're just looking at kind of an everyday use case, there shouldn't be too much of a problem. For source here, I've just put this as any source. However, what we could also do is use the CIDR used to generate our private IP addresses within the VPC. In terms of storage configuration, you can choose almost anything, but just a kind of regular low amount of storage. So I've chosen 45 gigabytes here, which is probably quite overly generous. And then we can launch our instance, which I'm not going to do because I already have a few pre-configured. Instead, let's tab over to this instances page and start up these parallel instances. Right, that's happened. So I'm going to stop the video now and resume it when these are fully started and initialized. Okay, these are running and initialized. So on to the next step. First off, what we need to do is we're going to go onto one of these instances. Let's get its public IP address, and we're going to SSH into it. Let's say this is going to be our master node, 1-0350. Okay, so here we go. get this, remove our old one, enter that. Now we're connecting, and we're in. Next thing you can see is this our pre-built Pytorch environment, which I kind of mentioned when we were building the AMI. You can just activate here. And then I've just gotten a GitHub kind of, I've got the GitHub scripts written in Pytorch examples for the DDP tutorial. I've just cloned that in to this environment. So let's navigate into the tutorial code. Oops. And here we are. So the script we're wanting to run is multi-node. So let's get that up. And so here we see the command we need to run. It's going to be Torchrun. We're going to, so we have 2 nodes. This is the master node, so it's rank 0. The rendezvous ID can be any random number. Our rendezvous backend is C10D, which is going to end up using NCCL, hence those random ports. And the endpoint is going to be 172.31.72.233. Let's look at that to confirm. Oops. 172.31.72.233. That's a match. Okay. So that is now looking for that. Next, we need to SSH onto our other one. Okay, we're going to source activate Pytorch. We're going to cd into examples, distributed, DDP tutorial series, and then again, run Torchrun. And this is the same command line argument, except our node rank here is 1 instead of 0. And you can see, here we go. We have a successful example of training across multiple nodes. So that's fantastic. And if we look over on the other instance, you'll see that that's worked here as well, and it's been assigned. This one is GPU 1, and this one is GPU 0. So that's effectively it. We've successfully done the multi-node training setup from the DDP tutorial series using Torchrun. Thank you very much for watching. And I hope this helps you train your models just a little bit better and a little bit faster. Thank you again. Goodbye.